Hello guys, welcome to my channel Dummy Node. Today we are going to talk about the question cousins of a binary tree. So let's first understand this question. So the conditions for two nodes to be cousins is nodes should be at the same height. So what does that mean? For example, 3 and 2 are of the same height. 7 and 4, these two are of the same height. 2 and 7, these two are at different height, right? So these two nodes cannot be cousins. So the first condition is nodes should be at the same height. So what is the second condition? Second condition is nodes should have different parents. So what does this mean? The parent of 2 is 1. The parent of 6 is 3. The parent of 7 is also 3. So you did the drill, right? So if the nodes are 2 and 3, parent of both node 2 as well as node 3 is 1. So these two are children of the same node. So these two cannot be cousins. But what if 2 and 6? These two have different parents. 2 has 1 as the parent and 6 has 3 as the parent. Can these two be cousins? No, they cannot be. Because 2 has 1 as its parent and 6 has 3 as its parent. But 2 is at a height 1, but 6 is at height 2. So these two cannot be cousins of a binary tree. So we understood the conditions on when we can call two nodes as cousins of a binary tree. Now we discuss about the constraints. So the constraint is the node values are always unique. So there are to be two nodes in the binary tree which have same value. So keeping all this in mind, we are going to approach the problem. So, how do we figure out the first step of the algorithm is how do we figure out the two nodes are in the same level? So, whenever we hear the word level or height, the first thing that should come to our mind is level order traversal. So, what is level order traversal? We can find out which nodes are in the same level. For example, 1 is in the same level, nodes 2 and 3 are in the same level. Node 4, 5, 6, and 7 are in the same level. Node 8 and 9 are in the same level. And node 10 is at a single level. So if you can write waves like this from a single node, it is level order traversal. So let's try to solve this problem. Let's have x is equal to 8 and y is equal to 9. The first step is we'll have a queue, and the only element that would be there in the queue is 1. And we'll check if x is there or y is there. No, both of them are not there. So we'll populate the next level. How do we populate the next level? We'll populate the childrens of 1, which are 2 and 3. So this would be the first level and this would be the second level. We'll check if x or y is present in the level. No, it's not. So we'll go to the next level. We'll populate the children of 2 and children of 3 in this level. And again the drill follows. We'll check if 8 is in this level or y 9 is in this level. No, both of them are not there. So we'll just continue the process. Now fourth child is 8 and sixth child is 9. Now we have both 8 and 9, which is x and y, in the queue. So now we have a layer which signifies that nodes 8 and 9 are there in the same level. And now we have to check if the parents are different, right? For that, in every level, we can have a parent pointer saying that what is the, so whenever we are populating layer, right, we know what is the parent of every node. For example, when we were populating 2 and 3, we would keep a note of what was the parent of 2 and what was the parent of 3, which was 1 in that case. We follow the same idea everywhere. So now also we know that the parent of 8 is 4 and the parent of 9 is 6. The first condition is if nodes have the same height, but the level order traversal, it is guaranteed that both of them are in the same height. And then we check if the parent pointers are same or different. So when we do this check, we get 4 and 6 as two different nodes. As we know, as 4 node is different from 6 node, we'll just say that we have found two cousins of a binary tree and we'll return true from it. And will not go to the next level. So what if this is one condition, right? What the second condition is, what if you just find one node to be in a level and other node it's not there? For example, what if x is equal to 2 and y is equal to 10? We get x is equal to 2 in the second layer itself, but y is not there. As the nodes are unique, right? As the constant mentions, the nodes are unique. So we know that one node is present in the second layer, but the other node is not there. We can instantly return false from here. This is called as pruning in the breadth first search. So now let's go and code the solution.
Let's start with the coding. So let's have a queue. It should have initially the root as an element, and while the queue is not empty, we'll process each nodes. For the next level, we'll have a dictionary. This would contain the node value as the key and the parent of the node as the value. And we should have another queue which will store the nodes for the next level, right? So this is another list. We'll traverse for all the nodes in the queue. If this node has left child, then we'll add this to the next queue. And we should also add it to the next level, right? To check for x and y values. So this value would be the key, the left child's value, and the value would be the parent. What's the parent for this node? The node. And we'll do a similar thing for right child as well. I'm just copy pasting it. So if node has a right child, I'll add the right child to the queue for the next queue, and I will use its value and have the node value and parent node dictionary set up. So here, when we complete this for loop, we have all the nodes which are in same height. At this point, we can check if x and y are there. So I'll say if x in next level and y in next level, both of them are to be present. And I also have to check the second condition, which is next level of x. This would give me the parent node for x. I'll check if it is not equal to next level of y. If all these conditions satisfy, then I'll return true here itself. Will not explore the next trees. Otherwise, I have to explore. And I also check. So this is the pruning part that I explained earlier. Pruning breadth first search. What we'll do is, if we'll check if X in next level or Y in next level. If either of the one is there, either of the node is present in present here, then we can just say return false. And after all this, if both are not there, then it will come till here. We can just update our queue to the next queue that we populated. So if X is not there or Y is not there, if both of them are not there, then the code will come till here. So that's an edge case we have to handle. So here we'll just return false. So let's see if this works. So it got accepted. So I'll just click the button. As you can see, it got accepted. 77.85%. It's faster. Thanks. So if you found this video helpful, please click on the like button and subscribe to this channel. Thank you.